Hello everyone, and welcome to today's session on AI agents. I'm excited to have you here as we explore this fascinating field. On this slide, you can see the title, AI agents, along with some key topics we'll be covering, including MCP, RAG, GenAI and LLMs, deep learning, machine learning, and the fundamental terms every engineer should know. We'll also look at the AI learning roadmap to guide your journey. Over the next few slides, we'll dive into each of these areas to build a solid understanding of AI and its applications. So, let's get started. Let's take a closer look at the evolution of AI. At the most basic level, we have what we call normal AI, which is essentially AI designed to make computers think, learn, and make decisions in ways that resemble human intelligence. This is the foundation of artificial intelligence as a whole. Moving forward, we see machine learning, which is a key part of AI. It's about training computers to predict outcomes and classify data. Think of spam filters that keep unwanted emails out of your inbox or recommendation systems that suggest products or movies you might like. Then we arrive at the exciting world of generative AI. This is where AI can create new content, like ChatGPT generating text or DALL-E creating images. It's learning from vast amounts of data to produce original, creative outputs. For example, it can even help predict house prices based on various factors. All these layers show how AI has evolved from basic decision-making to advanced, creative, and predictive capabilities. This progression is key to understanding how AI is shaping our world today and into the future. Let's talk about the advantage of being an engineer. A strong background in logic and math really sets you apart, allowing you to learn twice as fast as the average learner. This foundation accelerates your understanding across all areas of AI and data science. Moving forward, you'll see how this plays into building a solid portfolio, starting with 3 to 4 projects on GitHub and connecting with professionals on LinkedIn. As you progress, you'll focus on key topics like prompt engineering using LangChain and working with RAG, MCP, and APIs, which are essential for modern AI applications. Then, you'll dive into generative AI and large language models, or LLMs, which are transforming the field. Next, we explore neural networks, covering CNNs and RNNs, and advanced architectures like transformers, with tools like PyTorch. This deepens your understanding of deep learning. Moving further, you'll get comfortable with supervised and unsupervised learning, practicing with scikit-learn and Kaggle. Building this practical experience is crucial. Finally, you'll establish a strong foundation in Python, NumPy, pandas, linear algebra, and probability. This core knowledge supports everything else you'll do in AI and machine learning. This roadmap is designed to guide your learning efficiently, building from fundamental concepts all the way to advanced projects, leveraging your strong logical and mathematical skills to learn faster and more effectively. Let's explore how generative AI is transforming creativity across different media. With human-like voice cloning tools like 11 Labs, we can produce realistic speech that sounds just like a person. This opens up possibilities for personalized voice assistants or storytelling. Moving to videos, tools like Sora and Runway allow us to create videos simply from text prompts, making video production faster and more accessible. When it comes to music, platforms such as Suno AI and Udio enable us to generate original songs in seconds, empowering musicians and creators alike. For programming, GitHub Copilot can generate entire code programs based on natural language descriptions, streamlining the development process. We also see incredible potential in art creation. Using text prompts with tools like DALL-E and Midjourney, anyone can create stunning images without needing advanced artistic skills. Writing is no longer limited. ChatGPT and Claude help us draft emails, stories, or even complex code, making content creation more efficient. The key takeaway here is that generative AI isn't just about predicting what comes next. It's about actively creating new content across various formats, unlocking endless possibilities for innovation and expression. Let's take a closer look at how we can build powerful AI tools using LangChain, Llama Index, and FAISS. These tools enable us to create practical solutions like PDFs, chatbots, knowledge bases, and support bots. Imagine an employee asking, "What is the leave policy?" In this scenario, the AI reads the company PDF and provides an instant, accurate answer. For example, it might say, "You have 18 casual leaves per year, page 5. This demonstrates how AI can quickly access and extract relevant information from large documents. This process is part of a real example, a company PDF chatbot, where the AI reads your private documents and answers questions based on their content. The key steps involve loading the document, splitting it into manageable chunks, converting those chunks into vectors, and then finding similar chunks when a user asks a question. The core technology behind this is Retrieval Augmented Generation, or RAG. It combines traditional retrieval methods with generative AI, allowing the system to fetch the most relevant information and generate accurate, context-aware responses. So, with these tools, you can give your AI access to your private documents, and it will read and answer from them seamlessly. This approach makes knowledge management and support more efficient and accessible, empowering your team to get the answers they need quickly and reliably. Let's walk through how this process works. First, the AI interacts with the calendar MCP. It looks for free slots and then creates an event accordingly. Next, the Gmail MCP steps in to send out the invite automatically. So with just a simple command like schedule a meeting with Rahul and send him a calendar invite, the system takes care of everything seamlessly. This is made possible by the MCP protocol, which connects various tools like Slack, databases, web search, GitHub, Calendar, Gmail, and the AI itself, like Claude in this case. The key idea is that these tools work together, enabling the AI to take real-world actions on our behalf. The Model Context Protocol, or MCP, is what ties it all together. It allows these different tools to communicate and coordinate so that complex tasks, like scheduling meetings, happen automatically and efficiently. This is a big step toward more intelligent, integrated workflows that save us time and reduce manual effort. Let's take a closer look at the team of agents in action. These agents are designed to research, write, and send, working together seamlessly as a multi-agent system. Think of it as a coordinated team using multiple tools like search engines, email, and databases to accomplish complex tasks efficiently. Within this system, we also have specialized tool use agents. These are more focused. They use just one tool to complete a specific task, like a weather bot that provides weather updates. Then, there are simple agents, which are straightforward and perform a single function without much complexity. Now, all these agents fall into three main types of AI agents. Each agent has a given task or goal, something they aim to achieve. They remember the context of their work through memory, which helps them stay on track and handle ongoing tasks. They have access to various tools like web browsers, Gmail, or GitHub, which they use to gather information or perform actions. The core of the agent is its brain, powered by large language models, which think and decide what to do next. Breaking down the agent's operation, we see four key parts. First, they think and analyze the goal. Then, they decide on an action, like using a tool. They act accordingly, observe the results, and then repeat this loop until the task is complete. This react loop is fundamental. It allows the AI to be autonomous, to think, plan, use tools, and ultimately complete tasks on its own. So, giving an AI a clear goal sets it in motion to work independently, much like a dedicated worker in a team. Let's take a closer look at the core of this slide. The combination of RAG, MCP, planning, and autonomy. This is what we call the most powerful setup, and it truly transforms how AI agents operate. When we combine these elements, we get a full auto research assistant that can handle complex tasks seamlessly. For example, think about a Gmail or GitHub bot. It can automate your workflows, respond to your emails, or manage repositories automatically. We also have PDF chatbots, which can read and interpret private documents to answer your questions accurately. Now let's compare some features across different approaches. With RAG, MCP, and AI agents, we see significant advantages. They can take actions based on live data, meaning they can interact with real-time information. Think of live updates, current data feeds, or ongoing tasks. They can handle multi-step tasks, which means they can plan, execute, and adapt as needed, all without constant human intervention. They also think, plan, and take actions autonomously, connecting to live tools and APIs, reading private documents, and providing real-time responses. On the other hand, static systems lack these capabilities. They cannot access live data or handle multi-step tasks effectively. This combination of features, live data, multi-step processing, autonomous planning, is what makes these agents so powerful and adaptable in today's fast-paced digital environment. And that's the key takeaway. Integrating RAG, MCP, and planning creates a truly autonomous, intelligent system capable of transforming your workflows and data interactions. All right, let's explore some of the key resources available for learning and developing in the AI space. First, YouTube offers a wealth of free content, with channels like Andrej Karpathy and StatQuest providing clear, engaging tutorials that make complex concepts accessible. Moving on, GitHub is an essential platform for open-source projects, where you can find code repositories to learn from and contribute to. Next, the Anthropic documentation covers important topics like MCP and Claude, which are crucial for understanding advanced AI models. Similarly, LangChain's documentation is invaluable for working with RAG and agent-based systems, helping you build smarter AI applications. For those interested in practical skills, deep learning, AI offers free short courses focused on generative AI, giving you a solid foundation. Kaggle is another fantastic resource, offering datasets and competitions that provide hands-on practice to sharpen your data science skills. Fast, AI emphasizes practical deep learning techniques, making it easier to apply concepts directly to real-world problems. And finally, Coursera features courses by Andrew Ng on machine learning and Python, which are perfect starting points for building your expertise. All these resources together form a comprehensive toolkit, empowering you to learn, experiment, and advance in the rapidly evolving AI landscape. Let's dive into some of the key ways we can train and work with AI models. First, fine-tuning allows us to customize a pre-built AI model using our own specific data, making it more accurate and relevant to our needs. When we talk about giving AI a goal, we're referring to AI agents, systems that can think, plan, and complete tasks independently, almost like having a digital assistant that operates on its own. Connecting AI to real tools, like Gmail or GitHub, is what we call MCP, or multi-channel processing. This enables AI to perform actual actions within our existing workflows. Feeding AI your private documents, which is RAG, Retrieval Augmented Generation, helps it read and answer based on your specific information, making its responses more tailored and reliable. Prompt engineering is all about asking the right questions to get the best output from AI. It's a crucial skill for effective interaction. Then, we have generative AI, which creates new content, be it text, images, code, or videos, opening up endless creative possibilities. Deep learning, with its brain-like neural network structure, allows AI to handle complex tasks by mimicking how our brains process information. And at the foundation, machine learning is about giving AI data so it can learn patterns on its own, continuously improving over time. Overall, these concepts build on each other, from basic learning to sophisticated autonomy, enabling us to harness AI's full potential in innovative and practical ways.